we're going to start. Okay, today we're going to start factoring by looking at greatest common factors. Okay, we're first going to start by factoring type trinomials. If you remember, that means, whoops, 3 terms. And this is a form they're going to be x squared plus bx plus c. You've probably seen that before. But right now, we're going to start with greatest common factor to get us ready. Greatest common factor is something you should do always before ever factoring a trinomial. Now, what does factoring mean? Well, we worked on multiplying polynomials. If I multiply this out, I'm not going to show any work, but if I multiply this out, I would get x squared plus 5x plus 6. So now we're going to go backwards. I give you this and you find that. That's what it means by factoring. We go backwards. I give you the factor, the multiplied out form, and you're going to find how to put it in parentheses. That's what factoring means. You're given this, and you have to find this. Okay, so let's look at GCF. GCF is greatest common factor. You've done this before with other things in mathematics. If you find the greatest common factor, but we're going to do this in a factoring kind of form. So if I said to factor 9x plus 3, what does it mean to find the greatest common factor? That means I need to find the biggest number that I can take out and any exponents with variables I can take out. So what do they both share? You're going to ask yourself, what do all terms share? Whatever that is, you are going to do something called factoring out. Factoring out. When we had it in parentheses form, I'm going to scoot back up for a second. When we had it in parentheses form, we multiplied. So if I go back here for a second, we took this and we multiplied. So it's almost like opposite. It's what can I divide all my terms by? What is the biggest, that's the greatest common factor thing. What is the biggest number variable with exponent that I can divide all terms by? That's what you got to ask yourself. What is the biggest number or variable with exponent that all the terms can be divided by? So number one, the one I just wrote down, I see 9 and 3. I can divide both of them by 3, right? They're both are factors. That's 3. I know I could take a 3 out. But then look at the x. And by the way, I like to think of them in pieces. I look at my numbers, my coefficients first, and then I look at my variables. Notice I only have one variable. There is no variable with a 3. I cannot take out an x. They don't share an x. X is only with the 9. The only thing I can, quote, factor out is 3. And once you figure out what is the biggest variable number exponent that I can take out, you put it in the front with parentheses. And then you think to yourself, okay, if I took 3 out and we're talking about multiplying, I'm basically going to divide both of them by 3. What am I left with? Well, 9x divided by 3 is 3x, and 3 divided by 3 is 1. And that is my answer. I factored out the greatest common factor, which was only 3. Let me do one that has a variable as well, so you can see what it's like to do both. Oops, hold on, skip my page. Here we go. 2. Say I want you to factor this. By the way, this greatest common factor is a warm-up for what we're really doing. This is just skills to practice till we get to what we're really doing. 6x to the third minus 9x squared plus 12x. And if you can think these as pieces, think coefficient first. What number what's the biggest number I can divide all them by? And then what's the biggest exponent or x can I divide them by? So if I look at my numbers, I have 6, 9, and 12. What is the biggest number that I can divide all them by? Well, think your head, and the answer should be 3. I can divide all of them by 3. I can't go bigger than 3, but I can divide all of them by 3. Now look at each term. I have an x cubed, I have an x squared, I have x. They all have at least one x. Well, that means they each share one x. They all have one x. So I can divide, the most I can divide by is by 1x, because 12 only has 1x. Parentheses, that's my greatest common factor. What is left behind? Well, I'm going to divide each of them by 3x. And by the way, I'm going to show you divide by 3x, but eventually I want you to be able to do it without actually putting divide, which you will with a little practice. 6 divided by 3 is 2. X cubed divided by x. So I had 3 x's, I'm dividing by 1. That means I have 2 left, or x squared. 9 divided by 3 is 3. I have x squared. I had 2 x's, I'm dividing by 1. That means I have 1x left. And then 12 divided by 3 is 4. And x divided by x, that's just going to go away and become 1. And I just factored out my greatest common factor. When you do greatest common factor, anything in parentheses should not have anything left to factor out. Have anything left. Let me put it this way, in common. There should be nothing left that you can divide by. Nothing. It's done. That's how you know what's the greatest common factor. Let me do another one. It's going to take a little while. If you haven't done this for a while, or this is brand new to you, it's going to take a little while. I know if you did developmental math 2, you did this a little bit. If you didn't, you might not have seen this in a while. All right, number 3, 14x to the third, y, plus 7x squared, y, minus 7x, y. I do want you to realize that I cannot combine like terms. None of them are a like term. None of them have the same exponents on x and the same exponents on y. So I can't add them together. That's what it is. All right, so then what is, one at a time, look at my coefficients. What's the biggest number I can divide all those coefficients by? 7, exactly 7. So 7 goes out. Now look at your x's. What is the biggest x that they all share? How many x's do they all share? What could I divide all of them by? 1x, right? They all share at least 1x, because this one has 1 and no more. Look at y. What is the biggest y that I can divide all of them by? Well, they all have 1y. There's no exponents. So I can divide all of them by y. Whoops, wrong parentheses. Once you do that, you put your parentheses and you ask yourself, okay, now what's left? Well, I'm going to divide everything by 7xy. And we'll do one at a time. 14 divided by 7 is 2. X cubed divided by x is x squared. And y divided by y is gone. That's what's left for my first term. 7 divided by blah, blah, blah. 7 divided by 7 is 1. So I don't need the 7. X squared divided by x, that means it's x. Y divided by y, that's going to be 1. I don't need that. Minus 7 divided by 7, that's going to become 1. X divided by x, that's going to become 1. And y divided by y also becomes 1, which means I have 1 left. And I have my answer. Now, these are really nice because you can check your answer. How do you check your answer? Multiply it back through. If you distribute and multiply 7xy to all your terms, you have to come out with your original problem. And if you don't, you did something wrong. So when you first do these and you haven't done these in a while, I would 100% multiply that all the way through to check your answer, see if you did it right. So here's a little shortcut that I want to tell you about exponents. When you are factoring out a variable with an exponent, it's always the smallest exponent among all your terms. So when you factor out a variable with exponents, it is always the smallest exponent value that you will factor out. It always is. So if you have multiple variables, just look for the smallest exponent. That's the one you're going to factor out. I'm just going to make one up so you can see it. Okay, 4. Let's say I have x to the 5th, y to the 4th, minus x to the 3rd, y to the 7th, plus x to the 2nd, y to the 6th, plus x to the 4th, y to the 8th. Looks complicated, but think x and then think y. So look at my x. I'm going to actually circle these in red. Look at my x exponents. I have a 5, I have a 3, I have a 2, I have a 4. Which one's my smallest one? 2. So I'm going to be factoring out x squared. Then look at your y exponents. I have a 4. I didn't mean to do same color. 4, I have a 7, I have a 6, I have an 8, which is the smallest exponent, the 4. So 4 is going to be what I factor out for the y. So the greatest common factor of this is x squared y to the 4th. I'm still going to write this for a few more times. You can write this all the time if you want, but I do want you to get away from having to write it. I want you to realize what it means. So if I have x to the 5th, that's 5 x's, and I divide by 2, I have 3 x's left. If I have y to 4th, I divide by y to 4th, that becomes 1. I don't need it. Minus x to the 3rd divided by x squared, that's x. Y to the 7th divided by y to the 4th, that's y to the 3rd. Remember, when we divide, we subtract our exponents, but I like to think of it this way. I have 7 y's. I'm dividing by 4 y's. How many y's are left? 3. Plus x squared divided by x squared. Well, that's going to become 1. I don't need it. Then I have y to 6 divided by y to 4th, which is y squared, plus x to the 4th divided by x squared, which is x squared. And y to the 8th divided by y to the 4th is y to the 4th. And that would be my answer. All right, before I do any more, does anybody have any questions? I see shaking heads, everybody's good. Okay, let's practice a little more. I actually want to make a new page. Anybody have that caught up? Okay, so let me make a new page. I have 5. Whoops, 5. Let's look at 15, a to the 4th, b to the 3rd, minus 35, a to the 6th, b squared, plus 5, a to the 3rd, b to the 5th, minus 20, a to the 5th, b to the 7th. The first thing you always have to realize is that you can't add these. You can't put them together. None of them are like terms. So they have to stay like that. Now I'm going to do pieces. I'm going to look at all the coefficients and figure out what's the biggest coefficient number value I can divide them all by. So I have 15, 35, 5, and 20. I know I can divide all of them by 5. That's the biggest one I can do. So 5 is going to be factored out. I look at my A's. I'm looking at the exponents. I see a 4, a 6, a 3, and a 5. What's my smallest A exponent? A 3. A to the 3rd. Now I look at my B's. I have a 3, a 2, a 5, and a 7. Which one's the smallest? B squared. That's my greatest common factor. Parentheses. Now, if you, I'm not going to divide all of them by, we're going to sort of kind of talk it through, but 15 divided by 5 is 3. A to the 4th divided by A to the 3rd is A. B to the 3rd divided by B squared is B. Now, if you have to write this, feel free to. I'm going to try to sort of do it without doing that so you can see what it is like without it. What I'm doing is I'm taking each one, let me underline. I'm taking this and I'm dividing by that in my head. Well, not in my head, but without having to write it. So negative 35 divided by 5, that's minus 7. A to the 6th divided by A to the 3rd. Well, that means 3 A's are left. B squared divided by B squared. Okay, B's are gone. I don't have any B's left. Plus 5 divided by, now I'm over here. 5 divided by 5 is 1. I don't need to write 1. A to the 3rd divided by A to the 3rd, that's going to be gone. B to the 5th divided by B squared is B to the 3rd. And now I'm over here. Negative 20 divided by 5 is negative 4. A to the 5th divided by A to the 3rd. Okay, 5 divided by 3. So that means I have 2 left, A squared. B to the 7th divided by B squared. That means I have 5 left. And that's my greatest common factor. Most of the time, they're not going to be that detailed. It's that detailed so we can practice how to do these. Most of the time, you're going to see something like this. Something like that. That's what you're going to see most of the time. One variable with exponents and coefficients. But there's something really important about this particular problem, which I'm going to highlight, is that negative sign. All right, so I'll put it over here. If your polynomial has a negative leading coefficient, which is the first term, you must factor that negative out. as part of your greatest common factor. Especially as you move on, if you don't factor this negative out, you're going to have trouble factoring. That negative cannot be there. So you always want to start with a positive. So first thing I know, since the negative's here, I got to factor out negative. That has to be part of my greatest common factor. Then I'm going to look at my coefficients. I have 6, 12, and 24. What's the biggest number I can divide all them by? 6. Then I look at my x's and the exponents. I have an exponent of 3, 2, and 1. What's the smallest one? X. Parentheses. Now remember that negative is going to be, we're going to have to deal with that negative a little bit. So -6, I'm starting here. I'm doing this so you can see what I'm talking about. And I'm doing it to here. So -6 divided by -6 is 1. X to the third divided by x is x squared. So x squared, positive x squared. I took the negative out. Now 12, I'm over here now. 12 divided by -6 is -2. X squared divided by x is x. And now I'll go into my last term. 24 divided by -6 is -4 or -4. And x divided by x is 1, which we don't have to write. And that's my greatest common factor. So whenever you have a negative in front, you have to factor a negative out. Seven. 63y minus 33y squared plus 36y to the third. Now, interesting, that's not even in standard form. All the ones that we talked about, which I haven't mentioned before, were standard form. So I would not leave it that way. We have to rewrite it in standard form, meaning largest exponent to smallest. So I would rewrite it with my largest exponent first. Not so much when you have two variables, not so much. When you have one, you want it to be in standard form. Minus 33y squared plus 63y. Why? Because you need to know if that leading coefficient is negative or not. And it's not, it's positive. You could factor out the greatest common factor and then rewrite it as well. You don't have to do it the first step, but you have to do it eventually. Okay, so look at our numerical values, 36, 33, 63. They're a little strange, huh? But let's see. I could divide them by 3. They all are 3s. I don't think we do anything else. No, 3. Then I look at my y's. I have an exponent of 3, an exponent of 2, an exponent of 1. So my smallest exponent is 1. So my greatest common factor is 3y. Again, I'm just going to underline so you know where I'm at. So we're going to divide this. 36 divided by 3 is 12. Y to the third divided by y is y squared. Do you see how I'm doing each one at a time? I do my coefficients first, and then I do my variable second. Always think that way. It makes it that much easier if you just think one at a time. All right, now I am over here. Negative 33 divided by 3 is negative 11. Y squared divided by y is y. And now I'm at the last term. 63 divided by 3 is 21. And y divided by y is 1 that I don't need. And I just took out my greatest common factor. And I have one left I want to do, but I want you guys to try it before we actually do it together. I want you to try to see if you can find the greatest common factor and factor out just like we did.
I have a question.
Yeah,
So where you said up at the top, a little bit up, about how you factor out the negatives.
Mhm.
So is that like only for like a coefficient, like a number, or so like what
Yes.
if it just starts with like negative x?
That's two. You gotta take that, you gotta take that out. Good question. Actually, let me put that here. Hold on a second. Let's say I have negative, good question. Negative x to the 6 plus x to the 4th minus 3x to the 3rd. Yes, it also has to do with not a coefficient, anything that's negative. So I would have to factor this out. I would factor a negative out because negative's first and is in standard form. So you have 6, 4, 3. You want to look at standard form. What is the smallest exponent I have on x? That's 3. So that's what I would factor out. Negative divided by negative is positive. X to 6 divided by x to the 3rd would be x to the 3rd. Positive, I'm over here. Positive divided by negative is negative. X to the 4th divided by x to the 3rd is x. There's only one left. And now I'm over here. Negative divided by negative is a positive. 3 divided by 1 is 3. And x to the 3rd divided by x to the 3rd is just 1. So that would be my greatest common factor. So that's a really good question. Yes, it has to be, you want to look at it in standard form. And if it's a first term in standard form, and it's a negative, you have to factor it out, no matter whether it has a coefficient or not. Super great question. Did I answer that?
Yeah, thank you.
You're welcome. I love questions like that. Awesome. Okay, now this is the one I want you to try. X, actually, let's make it negative so you can try it. X to the 3rd, y to the 4th, z to the 5th. I gave you 3 of them, but you're going to do one at a time. Plus x to the 5th, y to the 2nd, z to the 4th, minus x squared y z to the 3rd. And give it a try. Remember, do one at a time. Okay, let's give it a try. See how you did. All right, so number one, I have a negative in my first, so I have to take a negative out. Second, I'm gonna look at my x's. I have a 3 exponent, a 2, 5, no, wrong one, 3 exponent, 5, and a 2 exponent. So x squared. Then I look at my y's. I have a 4 exponent, a 2 exponent, and a 1 exponent. So it has to be a 1. And then I look at my z's. I have a 5 exponent, a 4 exponent, and a 3. So if you did that to start, you did perfect. That's the greatest common factor. The hardest part about having a negative first is remembering that you have to divide that negative. So I'm going to, I can highlight anything. I think positive divided by a negative is a negative. Or where'd it go? Hold on. A negative divided by a negative is a positive. Think that way. Then I can do x to the third divided by x squared. And that means 3, take 2 away. That means I have 1. I forgot I had this little thing. It's really cool. X to the fourth divided by, sorry, y to the fourth divided by y. That means I take 1 away, which is y to the third. And then I have z to the fifth divided by z to the third, which means I have a z squared left. Good. Now, positive divided by negative is a negative. X to the fifth divided by x squared is x to the third. Y squared divided by y means I have y left, 1 y left. Z to the fourth divided by z to the third means I have 1 z left. And now negative divided by negative is a positive. X, whoops, wrong one. X squared divided by x squared, that's 1, so I don't have to write that. Then I have y divided by y, that's 1, I don't have to write that. And then lastly, I have z to the third divided by z to the third, that's 1. Okay, well, if 1's the only thing left, I have to write 1 because, whoops, when I distribute it back, it has to be able to be there. So if 1 is the only thing left, you have to write 1. 1 times 1 times 1, 1. How'd you do? Pretty good?
Side question, are we in we're in unit 3, but are we in 5.6 or 5.4? Or sorry, 5.5 or 5.6 right now?
I sort of kind of put them together. We're sort of kind of in 3, we're in 5.5 right now.
Okay,
Headed to 5.6. Sort of kind of put them a little bit together, but more 5.5. All right, so one thing with factoring that you can do is a technique called factor by grouping. Which uses greatest common factors. That's why we learn it first. Most of the time, not all the time, I think with me, probably all the time, you use factor grouping when you have four terms and you want to factor. You want to factor 4 terms. Of course, they have to be factorable, but if you see the directions factor and I give you 4 terms, you're going to use factor by grouping. And we're going to do a bunch of them to practice, but it's all about greatest common factor. The whole thing about factor by grouping is greatest common factor. So here's an example of a problem. 15x to the third minus 10x squared plus 6x minus 4. 4 terms, they cannot be simplified. They all have different exponents. 4 terms. So how do I factor by grouping? You sort of kind of do it backwards. You group them first. You take the first 2 terms and put them in parentheses. You should always, I know other people will tell you differently, but this will help you not make a mistake. Always have adding in between. And then you group the second 2. 6x minus 4. Now we're going to do the greatest common factor of each parentheses, not the whole thing, each parentheses. So we're going to look only at this one. What is the biggest coefficient that what's the biggest number I can divide both of coefficients by? 15 and 10, I can divide both of them by 5. I'm only looking at this. I'm not looking at the second one yet. Look at x. Whoops. What's the biggest, what's the smallest exponent for x? X squared. Parentheses. Now I'm going to do 15. I got to figure out what's left. 15 divided by 5 is 3. X to the third divided by x squared is x. Minus 10, whoops, wrong one. 10 divided by 5 is 2. And then x squared divided by x squared is 1. I already have a 2. I don't need it, the 1, because 2 times 1 is 2. Plus, now we concentrate on this one, the second parentheses. What is the biggest number I can divide 6 and 4 by? That would be 2. Parentheses. By the way, why can't I take an x out? Because 4 does not have an x. It has no x. So if it doesn't have an x, I can't take x out. In order to take an x out, they all have to have x. So 6 divided by 2 is 3. X is going to stay because I'm not taking x's away. Minus 4 divided by 2 is 2. And I just factor that. Now, I want you to really realize that, look at this. Aren't they the same? When you factor by grouping to do it correctly, they have to be identical. They both have 3x minus 2. So we are one step away from finding our answer. All right. What do they have the same? Write it down once, 3x minus 2. What's left over? What was not used? 5x squared plus 2. You just factored by grouping. What's the same? Write it down once. What's left over? 5x squared plus 2. Done. Factor by grouping.
Actually, I have a quick question.
Sure.
So I was wondering for like the original problem, if you can like basically defy standard formation or standard form to like if you like to regroup it. Does that make sense? Like even if like 15x cubed minus 10x squared, like could you regroup it even if it wasn't in standard form like that? That make
Yes.
sense?
Yeah, I think it does make sense, because one thing about factor by, I haven't mentioned it yet, but one thing about factor by grouping, let's say I did factor by grouping and I couldn't get these to be the same, my purple underlines. Whatever I did are not the same. What you're going to do is you're going to rearrange them and see if you can find a way that works. Now, not everything that's a 4-term polynomial can be factored by grouping, but Your homework, of course, is going to be factor by grouping. And what I give you is going to be factor by grouping because I'm going to say factor. But yes, you can, if this does not work, the next thing you want to do is regroup. So I might, let's say that it work. I might go, okay, well, I'm going to put these together because I can divide by 3, right? And I'm going to put these together because I can divide both of them by 2. And then I could try it again. So this could be my new group if it didn't work. So most of the time it works perfectly, but sometimes it doesn't work. If it doesn't work and you're told to factor it and you're going to factor it, then you will rearrange it and see if you can try it a different way. Does that make sense? Does that help?
Yeah, that helps. Thank you.
Okay, you're welcome. That's a great question too. I was looking at another one. Hey, factor by grouping. So actually, this is going to be a good one. This might be a perfect one for your question too. Notice it's not in standard form. I would try it in standard form first. So I think the first thing I would do is I rewrite it. Now, if it didn't work in standard form, I'm going to try it the way they gave it to me. Maybe there's a reason they gave it to me that way, because usually they give you it to you in standard form. But I'm going to do standard form first. Okay, it's standard form. So what I do is I'm going to group the first 2. Always put a plus. I'm going to show you one next, that the reason the plus is important. 4x plus 4. Okay, the first parentheses. I don't have any coefficients. I just have x's. So my smallest exponent is a 2. I can factor out an x squared. And when I simplify, if I take 2 x's out of 3, I have 1 x left. And then this is 1x. And then this is 1. If this is the only thing, if this is the only thing you have in a term, you have to put the 1. It's like a placeholder, so that when I distribute, I get the same thing I started with. If it's part of a whole bunch of things, you don't have to put 1. But if it's the only thing left, you have to put 1. Now, plus, what can I factor out of my second parentheses? Well, I can take 4 out. I can't take x out because the last 4 doesn't have an x. Then I can go 4x divided by 4. That's just x. And then 4 divided by 4. That's 1. So it worked out fine because I know I got these to match. That's what I want. If they match, I'm good. One more step. What do both of them share? X plus 1. What's left over? X squared plus 4. Factored by group. Now let me do one more that I can talk about why you want to make sure you did a plus sign. And some of you will be a little bit lazy and start doing it too early and you're going to mess up. So be careful. Okay, 3. I don't want to say lazy, but trying to make shortcuts. Let's look at this one. 3xy plus 2 minus 3x minus 2y. Well, I think I'm going to rearrange this one too. What do you think? I think so too. I think I'm going to put 3xy minus 3x, put my x's together. And then I'm going to put my y's together with my 2. Why? Because I see 3 and 3 together and I see 2 and 2 together. I honestly think you could probably do it the way they gave it to you. But there's more chance of luck if you put it in some kind of ordered fashion. All right, so then I put the first two in parentheses. Plus, this is why you want to do the plus. You need to take that minus sign and make it a negative. Always. You never want that negative on the outside. You always want a plus. So looking at my first parentheses, I can factor a 3 out. I can divide both of them by 3. I can also divide both of them by x. I can't take a y out because the last term doesn't have a y. So if I divide 3 divided by 3 is 1, x divided by x is 1, and all I'm left with then is y minus 3 divided by 3 is 1, and x divided by x is 1. Now, they're both 1, but it's the only thing left. I have to put 1. Now, remember we talked about when you factor, if the first one is a negative, you have to factor it out. We have to factor out not just 2, but -2. You have to take the negative out. When I take the negative out, -2 divided by -2 is 1. All I'm left with is y. Then +2 divided by -2 is -1. And then take a second and look, I have the same thing. I did great. I know it's right. Okay, so what do they share? Y minus 1. What's left over? 3x minus 2. Factor by grouping. Okay, but I will pause for a minute and see if you guys have any questions before I go on. You're doing great. Anything? No, you want to try one on your own? Of course you do. Why not? Okay, so let's try one. 4. 6 z to the third minus 27 z squared plus 14 z minus 63. Give it a try. See how you do. I'm gonna start doing it in silence. Don't look unless you want. Okay, whenever you want to look, you can look. I have the answer down. Okay, questions? Anything?
I'm sorry, I have one again.
No, go for it. Don't be sorry. Ask.
Okay, so you were saying that like sometimes, if like our answers aren't matching up at the
Mhm.
bottom, like
Mhm.
we may have to switch the formula around. So
Yes.
how is like, would you do that like at the beginning or at the end? Like, are you always supposed to have it in the beginning in standard form and then it lines up, or can it be different?
I would always put it in standard form first and then try it that
Okay.
way. Because more than not, it works in standard form, but once in a blue moon, once in a blue moon, it doesn't work and you have to rearrange it. I was actually going to show you something because while you were working, I went back to my problem. I actually want to do this problem over again. Where is it? This one, number 3, because I think I can fit it here. I didn't even have to rearrange it. I think it works without being rearranged. So actually, let me do it. So if I do not rearrange it, and I regroup it the way it is, will I get the answer? Now, sometimes they probably rate it that way. So that's the way maybe that works. I don't know. So if I look at my first 2, well, no, because now I'm stuck, right? I can't factor anything out, can I? I can't factor anything out of that either. Nope, I can't do it. So I had to rearrange it. But if I go back up here, one of them does work. I think it's this one. Let's say I do what they gave me. Sorry, my voice keeps going out. I could probably, I'm thinking in my mind, this will work. So let's see, I could take an X out. I'd be left with X squared plus 4. I already have an X squared plus 4, which is really important. I should probably talk about this. So what does that mean? That means I really have a 1 in front. If there's nothing to take out, you put a 1 because we have to do, what do they have in common? X squared plus 4. What is left over? X plus 1. And we got the same answer. We didn't rearrange it. So sometimes going to standard form, most of the time is going to work. This is one of these weird ones that rarely happens, but I could have done it the way it was. But I suggest always go to standard form first. And then if that doesn't work, then go back to the original or to try rearranging. I will tell you that it's rare you have to rearrange after standard form. That good? Actually, it's a good example. How I could not do it. This one cannot be done the way it is at all. You can't factor anything out. This one, I could have done it that way. Any other questions? We actually have really good timing. We have like 10 minutes left and I want to get you going on what we're going to do next. Now, Monday is July 4th and we don't have class, right? So next time I see you is next Wednesday. And this is where we're going to pick up with next Wednesday. So we're going to start looking at factoring, which is where I started the class with x squared plus bx plus c. So trinomials with x squared plus bx plus c. So now I guess we're officially in 5-6. Everything else was a warm up to 5-6. So my directions were factor. I just want to show you a couple of them just so we get it in your mind. I cannot stress on you how important this is. Before you do anything, after I show you how to do this, before you do anything, always factor out a GCF first. Always look for GCFs. Always look first. Always look for GCF first. Always. If you don't, you're gonna have a hard time factoring and maybe not even be able to factor at all. You always want to look for GCF first. This one has no GCF. I have no coefficient on x squared except 1, and 8 does not have an x, so I can't factor anything out. I don't have anything to factor out. So when we talk about factoring x squared plus bx plus c, that means that x squared doesn't have a value other than 1. When we come back, we're going to factor where it's not 1. There's actually a coefficient with x squared. But for right now, we're going to do without a value for the coefficient, just going to be 1. So factoring means this. We're going backwards. We're going into parentheses. Oh, somebody already has the answer already. Wow, good for you. All right, but I want to talk about something for a minute first. I want to talk about the signs. How do you know when you factor? Is it plus minus, minus plus, minus minus? Like, how do you know? Okay, so this is just something to get you started. And once you get started, you won't need to think about this anymore. But just to get you started, I don't want you to have to be hung up on signs. So let's say I have a polynomial, a trinomial that has a plus and plus. When I factor, I'm going to factor with a plus and a plus. So actually, let me put it in color so it stands out a little bit. If I have a plus and a plus in my trinomial, when I factor, it's a plus and plus. If I have x squared minus bx plus c, let me put that in color too. I couldn't do it at one time. Minus plus. When you factor, it will be minus minus. Any other combination is one of each. So I'll put a little line. X squared minus bx minus c. Let me put it red. When you factor, will be one of each, one positive and one negative. It doesn't matter which one's negative, which one's positive. It could be any order, but one of the parentheses will have a positive and one will have a negative. And which one am I forgetting? I'm forgetting this one. If you have a positive and then a negative, it's also going to be one of each. One of them is going to have a positive, one's going to be a negative. It doesn't matter where they are. It could be negative, positive, or positive, negative, as long as one of them is positive and one of them is negative. A way to remember it somewhat, if I have see this plus sign? See how they both have pluses? Then you use 2 of the sign before. So if these are both pluses, you use 2 signs of the sign before. Well, that doesn't make sense, does it? I didn't say that very well, did I? That just means if they're both positive and I have this one, it means I'm going to have a positive, positive because this is my positive. And this one's a negative. That means I'm going to have 2 negatives. And then ones that have a minus second, see the minus second? That's going to be one of each. But don't let that hold you up. We'll figure this out. So I want you to have this chart out, this chart right here. When we do this next couple times, I want you to have it out. I want you to look at it when we factor just to get you started. And then pretty soon you won't need it. Okay, so then how do we factor? I'm a very traditional factor person. There's all kind of fancy ways to factor. I would like to show you the traditional way because if you can do it the traditional way, you can factor anything eventually. Okay, so I look at this number, the C value. I need 2 numbers that multiply to be 8, but add to be 6. So 2 numbers that multiply to be 8, but add to be 6. So we look at our 8. 8 is either 8 and 1 or 4 and 2, or 8 plus 1 is 9. That's not 6, but 4 and 2 does make 6. So by my chart, I know it's positive, positive, and I know that I can do 4 and 2. You could do 2 and 4, doesn't matter the order. That's my factoring. 4 times 2 is 8. 4 plus 2 is 6. So the last value, the constant, 2 numbers that multiply to be that constant, but add up to be that middle value. Two. X squared plus 13x plus 30. And by the way, you're nowhere near ready to do this homework. You can do 5-5 homework, but you're not going to be ready for 5-6. And actually, it's really scheduled for next time we meet. I just want to get it started. Yeah, Amber, you're right. I like that. All right, now, 30 has lots of things that multiply, right? I need 2 things that multiply to be 30, but add to be 13. So we can look at things that multiply to be 30. We have 6 and 5. 6 plus 5 is 11. That's not 13. 30 and 1, but 30 plus 1 is 31. 5, I did 5 and 6. How about 10 and 3? Wait, 10 times 3 is 30, and 10 plus 3 is 13. So I also know, because I have plus and plus, my signs are plus and plus, and I know 10 and 3 will work. So 10 times 3 is 30, but 10 plus 3, actually, I'm gonna write it down. 10 times 3 is 30, and 10 plus 3 is 13, which is what you wanted. How can you really check? You're going to FOIL or double distribute them, and you can check all your answers.